So, welcome dear students. Today's session was scheduled for Deepak sir, but today he's not able to come. So, today myself Ankit and I'll be taking your session for JEE Bytes of Gravitation. So, hello Moin, hello Divyansh. So, student, welcome to the session. Hello Parth. So, students, as you all know, you have learned 5 chapters of mechanics. Now, this chapter is relatively easier as compared to the other chapters. So the question that come from this chapter, they are kind of easier as compared to the other chapters, right? So hello Parth, hello Brad Kishore, hello Arkaj, hello Vinday, hello Monu, hello Arkaj. Yeah, Arkaj, I remember you. Hello Mr. Singh. So students, welcome to the session. So today we're going to talk about gravitation. Now, let's start with a question, and I'm going to tell you the concept. Okay. So welcome everyone. So students, the question that came in JEE Main 2011, the question says that two bodies have masses m and 4m are placed at a distance of small r. The gravitational potential at the point on the line joining them where the gravitational field is 0. Student, we have to find a point, the gravitational potential at a point where the gravitational field is 0. Okay. So, as you all know, what is the formula for gravitational field? What is the formula for gravitational field? If you want to know about gravitational field, what is the gravitational field? Gravitational field. Wait a while. So, yes, this chapter is from JEE point of view. Okay. There's some problem, there's some technical issue. Wait a while, students. Wait a while. So basically, gravitational field we have to find. So, what is the formula for gravitational field? What is the formula for gravitational field? Basically, gravitational field is what? That is force that is applied by a body of mass capital M on a unit mass, right? So, for example, here is a point mass of mass capital M. So, at a distance of capital R, let's say at this point, let's say this point is A, P. So, at point P, gravitational field is equal to, given as E is equal to Gm by R square. Okay. And students, you know that gravitational force is always attractive. So it is always directed towards the mass, the point mass. Okay. So now the question says there are 2 point masses, two bodies of mass m and 4m, and they are placed at a distance of small r. So we have to find a point where the gravitational field is 0. So this is point A. Let's say this is the point of mass small m, and the other one is of mass 4m. So let's assume that the point lies between them. You should be clear about this thing, that the point should be lying between them only. Because gravitational force is always attractive, or gravitational field is always attractive, you can say. So if you want to calculate gravitational field at this point, let's say at this like a point lying towards left of small m. So for small m, it will be towards right, and for mass 4m, again it will be towards right. Okay, so here it cannot be 0. Towards right also, if you want to find a point, here also the gravitational fields will have same direction towards the left. So that's why the point should lie between them. Okay, let's say at point P, the gravitational field is 0. Okay, so let us say that it lies at a distance of small x from mass of small m. The point P lies at a distance of small x from point mass of small m, and as you all know, the distance between m and 4m is given as r. Okay, it's given as r. So the other part, that means the distance between point P and 4m will be r minus x. Okay, so this distance will be r minus x. Okay, so now at point P, if we are assuming like that the gravitational field is 0, so you can see that the gravitational field at point P due to small m will be towards left, and due to 4m will be towards right. So we can do one thing. We have to equate gm by x square with g into 4m by r minus x square. Okay. So after this, students, you can calculate. Now g and g can get cancelled, m and m get cancelled. So we can say 1 by x square is equal to 4 by r minus x whole square. Or I can say this thing, that 1 by x is equal to 2 by r minus x, right? So from here, students, if you find the value, you'll get x is equal to r by 3. Okay, x is equal to r by 3. So we have got the point where the gravitational field is 0. At point P, the gravitational field is 0. Okay, so we have to find the potential at point P. So what do we mean by potential? What is the potential? What is gravitational potential, students? Do you have any idea? What is the gravitational potential? Yes or no? Tell me first. Do you have any idea of gravitational potential? What do you mean by gravitational potential? So basically, you can say that it's the work done. See, okay, no problem. If you have no idea, let me tell you. Now let's say this is mass capital M, and we are bringing a unit mass, let's say 1 kg, from infinite to a given point. Okay, so be clear about this thing. This concept is very important. Whether you are studying gravitational field, whether you're studying electric field, this concept is very important. So the work done by external force, okay, the work done by external force in bringing a unit mass from infinite to given point without any acceleration is known as gravitational potential. Okay. So basically, if you can see, students, the work done by external force in bringing a point mass from infinite to given point will be negative. Yes or no? It will be negative because gravitational potential is towards left. Because gravitational force is always attractive. Gravitational force is always attractive. So the body has a tendency to accelerate in left direction. So the external force has to be applied towards right. So that's why gravitational potential is always negative. Okay. So for a a point mass of capital M at point A, that is at a distance small r, the gravitational potential is given as minus of gm by capital R. This is the formula for gravitational potential. Okay. Now we have to find the total gravitational potential at a point where the gravitational field is zero. And in this question, we have found that that point lies at a distance of r by 3 from the mass small m. Okay. And that means this point at point P. So you can see that this distance is small r. And this distance is r by 3. So that means the other part will be 2r by 3. Right. So you can see the recording later on, Meghna. Okay. Now, gravitational potential at point P will be minus of gm by r by 3 plus minus of g into 4m divided by 2r by 3. If you solve it, you'll get the value minus of 9gm by r. So that is the correct answer. Okay. So student, please focus. You'll get everything. Okay. Now, this question is quite important from the concept of circular motion, or you can say from gravitation. So let's read the question first. The question says 4 particles, each of mass capital M, are an equidistant from each other, moving along a circle of radius capital R under the action of their mutual gravitational attraction. The speed of each particle is, we have to find the speed of each particle. So now students, you can understand here, there are 4 particles of mass capital M and they are equidistant from each other. Okay. So that means you should be clear about that the 4 points must be lying on a square. Okay. They must be lying on a square. So let's say this is point mass of capital M, and this is also a point mass of capital M, and this is point mass of capital M, and this is point mass of capital M. So all of them are moving in a circle. So, and there is no other force except gravitational force. So you should know that for moving something in a circular motion, a kind of force is required. We call that force as centripetal force. Right? You should be clear about that. That in order to make something of, let's say, of mass small m, to move something in a circle of radius small r, a force is required towards the center of the circle, and the magnitude should be equal to mv square by r. And that force is called centripetal force. So in this given case, in this given case, the net gravitational force on each particle must be acting as the centripetal force. Okay. So let's draw the diagram first. So this is a circle on which the particles are moving, and let's say this is particle number 1, this is particle number 2, this is particle number 3, and this is particle number 4. So students, now among each other, they are applying gravitational force. Okay. On each other, they are applying gravitational force. Okay. This is circular motion. It's given in the question that due to gravitational attraction, okay, the particles are moving in circular motion. It's given. See, it's given in the question that they're moving in circular motion. So because of gravitational attraction, you have to understand this thing. Okay. So now, what is the formula for gravitational force? Simply, F between two particles is equal to gm1 m2 by the distance between them square. This is the formula for gravitational force, and the gravitational force is always attractive. So we will consider only one point. Okay, let's say we consider point number 3. So tell me one thing. How many gravitational forces are acting on point 3? Tell me. How many gravitational forces are acting on point 3? You can understand that there are 3 particles except point 3 that are applying gravitational force on it. Very good, Braj Kishore and Bhagyashree. So there are 3 particles applying gravitational force on point number 3. So it should be clear to all of you that the gravitational force in the given case, the net gravitational force should be acting toward the center of the circle. Let's say how. Now students, as you all know, this is a square. 1, 2, 3, 4 make a square. And as you all know, the sides of square are equal. So that means the distance between 2 and 3 and 4 and 3 are equal. Yes, they are applying gravitational force. Okay. So if we talk about gravitational force between point 2 and 3, what is the value of gravitational force? You can see it's equal to g m into m divided by the distance between them. So how to find a distance between them? Students, you can easily understand that as this is a square, as this is a square, so that means this angle must be 45 degree. Okay, and this angle should be 90 degree. By congruency, you can prove. Okay, by congruency, you can prove. So this angle is 90 degrees. So that means 1 and 3 make a hypotenuse. Beta Sanjay, we have written the gravitational force formula. You can see it's written on the screen. So the distance between 1 and 3 is 2r because the radius of the circle is r. So 2r is the distance between the point 1 and 3. So you can find a distance between 4 and 3. Let's say that this distance be x. So this distance must be x because it's a square. So you can say x square plus x square is equal to 2r whole square. And you can say 2x square is equal to 4r square. So x square must be equal to root 2r. Sorry, x should be equal to root 2r. Okay. So x is equal to root 2r we have got. So what is the force between particle 3 and 4? you can say it's equal to gmm by x square, or you can say it's root 2 r whole square, right? So that is the force between particle 3 and 4. Similarly, the force between particles 2 and 3 will be same. It should be gmm divided by root 2 into r whole square, right? Okay, so you can see recording if you want to repeat. So students, you can see now these two forces are equal. Okay, so these two forces are equal. Let's say their magnitude be capital F. So what we can do, we can resolve the force between 3 and 4 and between 2 and 3 and two components and two perpendicular components, you can see. So you can see that. Wait a while. So let's say this is the force can be resolved in two directions, one along the diameter and one along the line perpendicular to the diameter. So that means if this is capital F, if this force is capital F, we will have F cos 45 degree here and F sine 45 degree here. In the other case also, we can see F sine 45 degree is towards right and F cos 45 degree is towards the diameter. Okay, so you can see that the sine components will cancel out. Yes, they get cancelled out. So now you can see F23 and F34 resultant is acting towards the center. Now if you talk about force between point 3 and 1, that force is also acting towards the center. Yes or no? You can see that the force between 3 and 1 is also acting in the direction towards the center. And what is the magnitude of that force? The magnitude of that force is equal to F13 is equal to gmm divided by 2r square. Okay, so when we have to find the net force, see we can see that the cos components and the force F13, they are all acting in the same direction. So we can just add them all, right? We can add them all. So what is the net force? Net force on particle number 3 is equal to, wait a while, it's equal to F on particle number 3 is equal to gm square by 4r square plus, you can say the cos components of the F23 and F34. So 2 into gm square by root 2r, you can say that it's 2r square into cos of 45 degree, right? So after that, we got the value to be equal to gm square. We can take gm square common, right? And r square also we can take common. So, and cos 45, you all know it's 1 by root 2. So we can write it as 1 by 4 plus 1 by root 2, right? So this is the net force, and you can understand that net force is acting towards the center. So this force will behave as centripetal force. This force, the net force, will behave as centripetal force, right? So what we have to find? We have to find the velocity, or you can say the speed of each particle, right? So just equate this with mv square by r. Just equate with mv square by r, capital R. Let's see how to get that. Simply gm square by r square into 1 by 4 plus 1 by root 2. And that's equal to mv square by capital R. Okay. And from here, you can easily say R and R can be cancelled. M can be cancelled. So V is equal to square root of Gm by R into 1 by 4 plus 1 by root 2. So in the question, let's see the options. So students, you can understand that the option 2 fits the best. You can easily adjust it like that. Simply, you can take LCM and you can find that the value of velocity is equal to 1 by 2 of Gm by R into 2 root 2 plus 1. So that is the final answer. So how we have to find that? Simply you have got it. Actually, this is the this formula of velocity we have got from centripetal forces formula, Sanjay. Okay. So let's see one more question. The question says, a planet in a distant solar system is 10 times more massive than the Earth, and its radius is 10 times smaller than the escape speed from the Earth is 11 kilometers per second. So the escape velocity from the surface of the planet would be, we have to find the escape velocity of the planet. Okay, we have to, what we have to find, we have to find the escape velocity of the planet. Now that must be clear to all of you. What is the formula for escape speed? What do we mean by escape speed? It's a minimum speed that is required by an object to move away from the gravitational effect of Earth or any planet, right? So student, you should be clear about that thing, that escape speed, its formula is given as simply for a, let's say for a planet whose mass is capital M and radius is capital R, the formula for the escape speed is given as under root of 2 2gm by R, or it's equal to root 2g into R, where small g is the acceleration due to gravity. Okay, so now you should be clear about that thing, that this escape velocity's formula, okay, escape velocity, it's independent of the mass of the body. It doesn't depend on the mass of the body that is actually thrown. Okay, and also it's independent of the angle, okay, of the mass of the body that is projected, right? And also it's independent of the angle. Okay, independent, because you can see in the formula there is nothing like angle, right? So it's independent of the angle also, and of the angle of projection, right? Now let's see the question. The question says, so for a planet in a distant solar system having mass 10 times more than that of Earth, so let's say, now see students, what is the value of escape velocity from the Earth? You can see it's 11 kilometers per second, right? So 11 kilometers per second is equal to under root of Gme divided by Re, where m is the mass of Earth and Re is the radius of Earth. It's given in the question, okay? Although it's 11.2 kilometers per second, it's given the question that came in JEE. Okay. Now for the planet, the given planet, its mass is 10 times more than that of Earth. So its mass is 10 m. Okay, mass is 10 times m, and radius is 1/10th of the Earth's radius. Right? You can see it's 10 times me, and radius is re by 10. Okay. So from here, you can see that this is the escape velocity for the planet. So it becomes 100 times GME by RE. So 10 times of that of root GME by RE. So that's why the correct option is C. Okay. You can write 2. No problem. You can write 2 because it doesn't affect. Okay. Okay. It doesn't affect the answer. See, it's given root 2 GME by R is equal to 11 kilometer per second. Okay. So now, students, so to know more how Meritnation can boost your preparation of JEE 2019, you can see the link that is given onto the screen. Okay. So thank you very much for attending the session. So daily we have sessions like this. So thank you, students. See you next session.